All right, let's see how stupid I am today. I'm already looking for my notes in a panic-stricken way. This is Bivariate Datasets, the unit test. Before you begin, the last question on the test asks you to match terms with their definitions. Screwing up one answer means you've automatically screwed up on a second one. This one question is worth multiple points and can drop your grade quickly. Make sure you know the definitions of the following terms before you begin the test, and take your time with the last question. Don't bomb the test because you're sick of testing and want to be done. Make sure you know what the definitions are for causation, bivariate data, association, linear regression, two-way frequency table, correlation, correlation coefficient, and categorical data. Okay, it's going to give you examples, like it'll give you little definitions of it at the end. I'll give you a little sneak peek of what it looks like. This is what you're going to have to be able to answer and sort into the correct things. Make sure you can do that, okay? Pause the video, get all that taken care of before you actually begin testing. Don't blow the whole test over this stupid, silly little question, okay? Here is number 1. This is the actual question, so I will show you, tell you, guide you on how to answer this, but I'm not going to answer it for you. Kyle includes this table in their report on the dogs they walk. They want to add another example of categorical data. Which of the following options would be suitable? So your two choices for this are either categorical or numerical. Numerical data is numbers. All three of these categories are numerical because you can see they have numbers. So if you have a category that can be written as a number, like how many Dachshunds you had or Basset Hounds or Great Danes, that's numerical, okay? If it cannot be written as a number, then it's categorical. So an example of a categorical would be like, let me think of one that's not given here. An example would be like type of food or brand of food. Okay, I can't write down brand of food as the brand is not one. The brand is like Purina or Pedigree or Dog Chow. Okay, so categorical is not a number. Anything that's written as a number is numerical. Okay. Here's number 2. Review the two-way frequency table. What are the missing values? Okay. So this is just like an algebra problem. If you know that there's 25 third graders and there's going to be, oh, this one I can do. This isn't the actual problem. Okay, I'll walk you through it. I fixed this one so that I could show you an example. Okay. So we know that there's 25 third graders and that there's going to be 37 total. So this would be the same as doing 25 plus something, we'll call it x, is going to be equal to 37. And if we're going to solve for x, then we'd subtract 25 from each side to find out what x equals, right? So x equals 37 minus 25. I'm going to use my calculator because I don't trust myself. And you should know by now that you shouldn't trust me either because I am a grade A screw up when it comes to math. So 37 minus 25 is 12, okay? So our answer in this box should be 12. Now, because this is a chart, we can check this. 12 plus 38, does that equal 50? It does, so we know this is the correct answer. Let's do the same thing for this problem. We have x plus 38 is going to be equal to 63. So to find out what this 38 is, remember, these are not your numbers. Your chart is different. Your answer is not 12. I am showing you how to find it, okay? So I need to get rid of 38 over here to get x by itself. So we're going to subtract 38 from each side, which is going to leave us with x is equal to 63 minus 38, and that gives us 25. And we can double check that this is the right answer because is 25 plus 25 50? It is indeed. Again, these are my answers. These are not your answers. Your numbers are different in the table. These are the steps you need to take to find your answer. Here's number 3. This is the actual question. I won't give you the answer. Based on the two-way frequency table, what is the marginal relative frequency of people who play winter sports? Round your answer to the nearest whole percentage. Okay? So people who play winter sports, we're dealing with this column. Okay? This is everybody that plays winter sports. So we want the total number right here. You're going to take this number and divide it by everybody that was interviewed or was part of this study. So it's going to be 157, whoa, come on, divided by 287. And that will give you your answer in the form of a percentage. Now remember, this will probably give you a decimal place, and you have to convert the decimal into a percentage. Your percentage is not going to be, I'm making up a number here, 0 point, triangle square, okay? To get the percentage, you have to move this to decimal places, and then you have a percentage. I believe in you. You can do this, okay? Here's number 4. You have gathered your grades votes for favorite ice cream flavor and topping. Then you organize the data into a two-way frequency table. Interpret the data to generate a two-way table of conditional relative frequencies for students who prefer sprinkles or jelly beans, given they prefer chocolate or vanilla. Round your answers to the nearest whole percentage. So we're dealing with percentages here. I have to go let my dog in. This is the actual problem, so I'm not going to solve it for you, but I will guide you on how to solve it, okay? So we know here that people who like sprinkles and chocolate, let me change my color, is right here, okay? Sprinkles and chocolate, and it's 34%. So let's verify that we know how to do this correctly. That means we do sprinkles and chocolate, which is 65. I'm going to put that in my calculator, divided by the total for this, for sprinkles and chocolate, which is 167. And look at that, I did it wrong. So let's go sprinkles and chocolate, 65, divided by 190. And there I got the right answer. Okay, so we're going to use this total, okay? We're ignoring this line. Wrong, we don't care about him. So that gives us our 34% right here. Now let's do it for jelly beans, okay? For jelly beans and chocolate, we've got 125 divided by 190, and that gives us our, it's really 65.7, but that gives us our 66%. So you're going to do the same thing for vanilla now. People who like vanilla and sprinkles are 102 divided by their total, which is 175, and that will give you this. And then jelly beans, vanilla and jelly beans is 73 divided by 175 will give you this percentage. Here's number 5. A group of 9th grade math teachers collected the data in the table about the grades of students who are involved in extracurricular activities compared to the grades of students who are not involved in extracurricular activities. What percentage of students who are involved in extracurricular activities have a GPA above 3.0? So we're dealing with above 3.0 and involved in extracurricular activities. So we're dealing right here, okay? And we need to figure out the percentage of the students that are involved in extracurricular activities and have a GPA above 3.0. I'm guessing we're going to go here. And there's a way we can check this, okay? So I'm going to use a different one. We're going to come here for my example, okay? We're going to say not involved in extracurricular activities and GPA below 3.0. This is not your answer, okay? This is my example, all right? So we're going to say we have 38 people that are not involved in extracurricular activities with a GPA below 3.0, and we're going to divide that by 60, okay? And this one would give us 63%, okay? Now to see if we can get our 100% here, I need to do the same thing right here, okay? So we're going to say if they are involved in extracurricular activities, which is 12, and a GPA below 3.0, we're going to divide that by 80, and that gives us 15%. That is not going to give me my 100% total, so I can't do it this way, okay? So I know that I don't want this column. We're going to do it the other direction. I'm going to show you how I can verify that. We're going to use this one again so that I'm not helping you cheat. Okay, we're going to say 12 divided by 50 gives us 24. Okay, and we're going to do 38 divided by 50 gives us 76%. This 6 and 4 gives us 1, which would make it 30, and there's our 100%. Do you see how I got that? Sorry, I wrote that in the wrong place. Okay, so we know that we can get 100% when we go vertically, but not horizontally. So this one is out. Okay, so we're dealing with this one, which means of the students that are involved in extracurricular activities, what's the percentage of people that have a GPA above 3.0? You're going to use this cell and this total to find your answer. So 68 divided by 90, which will give you the percentage. Remember, it's not going to be a decimal place. You need to adjust it to make it a percentage. Here's number 6. Create a scatter plot for each of the data sets shown. Distinguish which set of data represents a negative linear relationship. So in order to do this, we are going to go over to GeoGebra.com, and I'll show you how to make the first one as a scatter plot so that you can see that process, and then it's your responsibility to do the rest and figure out which one has a negative linear relationship. Negative means it slopes down from left to right, and linear means it's a straight line. There's not going to be a curve. Okay, we don't want a curve. So we're at GeoGebra. We're going to start our calculator. Okay, now all of these points we can make a table out of. So select table. These are written in X, Y format. So our X values are going to be the first number in each set of parentheses. So we have 0, 1, 2, 3, 4, and 5. Our Y values are the second number in each set of parentheses. So 0, -1, 12, 7, -4, and 5. Okay, zoom out over here so you can see what's going on here. Okay, and this, if we connected it with a line, the line's going to be something weird, or the line of best fit is going to go somewhere through here. Okay, so you can see from this that this is not linear right from the get-go because there's not a straight line. So this one is obviously not your answer, but you need to do the same process for data sets B, C, and D, and then figure out which one is a negative linear relationship. This one is my very favorite question in the whole assessment. I am really hoping that it's like this just because I was in the preview, not the actual assessment, because this is literally all the information that it gave me. Use the image to answer the question, and then it gave me options. That's it. There's no way to answer this question, which is why we have this nice picture of poop there to guide us. There's no way to answer this question. The only thing that I can assume is we're dealing with height. So if this is all you have, this is my best guess because I've taken way too many tests through my life. Okay, so we're dealing with height here. So 2.1 microns high is right here, and there's only one dot. 12 microns high is about here. Okay, 10 microns high is about here, and 49 microns high is not even on here. So that's not going to be an option, whatever the actual question is. I'm hoping they give you more information. I'm going to guess that it's probably going to be this one because there's only one dot for 2.1 microns high. Okay, and everything else there's two dots. So this one is an outlier. This one's strange compared to all of the others. Regardless, whatever answer you put in, if this is all that shows up, if there's no actual question, put in your answer, and as soon as your test is over, immediately email your teacher. Take a screenshot of this garbage and then immediately email it to your teacher and be like, yeah, this is the question on the test, because this you cannot be held accountable for. This is complete garbage. How are you supposed to answer a question when there is no question? You can't. Be polite though. Don't be acting the way I am. Okay, use GeoGebra to determine the least squares regression line for the points in the table. Round to the nearest hundredth if necessary. Okay, so I'm not going to answer this for you, but how you do this is you go to GeoGebra. You're going to use the algebra function. Okay, you'll enter Oh no, I'm sorry. You'll use the table function. You'll enter all these points into the table function. Okay. Then it will say, this will be labeled y sub 1. And right next to it, you're going to click the three little dots. And you're going to go down and click regression. Okay. And that will take you to a pop-up. And you can scroll down and the formula. Oh, no, you can just scroll down and click plot. You don't need to make it any more complicated than that. Okay, it will plot it on there. And then you're going to click on the line and then click the little box that has the two A's in it and click the box that says show value. And your equation will show up next to your line. And your equation should be one of these. Okay. Here's number 9. Gianna recently bought a used car. She keeps track of the number of miles she drives each month. The table displays the number. I didn't put the table. I'm such a winner. Displays the number of miles on her car after the given number of months. If the slope of the line of best fit is 1,727, which of the following options is the correct interpretation of the slope? Okay, it doesn't matter that I didn't put the table, but you can use the table if you want to, okay? If this is the slope, we know that the formula is y for a linear formula is y equals mx plus b. We know that m is the slope, and it told us right here the slope is 1,727. Okay, slope is also written as rise over run, which is the differences in y over the differences in x. Okay, so if this is our slope, this is really over 1. We just didn't write it that way. Okay, because we never write over 1 because everything is really over 1. So this should answer your question. Your graph is going to look like this. This is going to be miles, and this is going to be months. You should be able to answer the question from that. If we are going rising 1,727 miles and then going over 1 every time, rising 1,727 over 1, which one of these makes sense? Okay. Here's number 10. Charles wants to go on a fishing trip. The price of the excursion varies based on the length of the trip. The line of best fit for these data is y equals 50x plus 75, where the price of the trip is based on the number of hours of the trip. What prediction can be made about the length of his trip based on the line of best fit? So you're going to go to GeoGebra.com. You're going to use the algebra function. You're going to enter that formula in, and it's going to graph a line for you. You're then going to use that graph and move it around and zoom out, in and out, move up and down to see which of these statements is true. So for $200, Charles can travel for 2 hours. The money is going to be right here, and the hours is going to be down here. So for this first one, you would find where 2 is, and you would scroll up to wherever 200 is and see, is the line right there? Do we have a point that matches right at 202? If so, this is your correct answer. If not, that one's out. Okay. You would do the same thing for 3 hours and 300 and see if it's true. Then you'd look at a 6-hour trip, so 6 hours and 400. And this says you can take a 6-hour trip for less than 400, so that means the line would be under where 6 and 400 cross. Okay. And then it says you can go on a 1-hour fishing trip for less than 100. So that means that you'd have one hour, $100, and the line would be under it. That would make that a true statement. Here's number 11. What is the value for y hat given the table? Okay. Here's the table. And then these are your possible answers. It tells you right here that y hat is this formula. Okay. So what you're doing here is you're going to take these numbers, plug them in for y hat. So for example, your first one would be 59 equals 5.5x plus 16. Okay. And then you're going to solve it and see. Let me think for a minute. line of best fit. What is the value for y hat? Given the table. Okay, no, I'm doing this wrong. I'm leading you astray. I remember now. Ignore that. What you're going to do is you're going to do y hat is equal to 5.5, and then our x value is right here because this is x, y, y hat, and then residual, okay? And the residual is y minus y hat. So our x value is 8. I apologize for that. Plus 16. You're going to solve for that, and whatever answer you get should be one of these. Okay. Number 12, determine the reliability of the linear model given this residual plot. So one of these, there's 2 pages of answers for this, but what you need to know, reliability means you have your residual equals 0 line right here. You want dots above it and below it. You want it to be random. You want there to be no pattern. The patterns that you don't want to see, you don't want to see a straight line. You don't want to see an exponential line. You don't want to see a parabola, okay? You want to see completely random. You don't want to be able to draw a line through any of it. That means that it's highly reliable, okay? A good plot is completely random. So you'll have to figure out what this plot is saying. Is it reliable? Okay. Here's number 13. To create a residual plot based on the given scatter plot, how many values would be located below the residual equals 0 line? So this is the residual equals 0 line, okay? So you can take this plot and make it look like this, okay? But we don't have to do that. We can look at this and we can say anything that's above it is still going to be above it here. Anything that's on the line is still going to be on the line here. Anything that's below it is still going to be below it here. So look here and see how many dots are going to be below the residual line on the new graph. Okay. Here's 14. Find the correlation coefficient of the following table using GeoGebra. Round your answer to the nearest hundredth. Okay, so to find the correlation coefficient, you're going to go to GeoGebra, open your table. You're going to enter all of your XY values, and it's going to automatically graph it for you. To find the correlation coefficient, you're then going to click the 3 vertical dots that are next to your Y1, this Y sub 1. This will automatically be labeled Y sub 1 in your chart. And you're going to scroll down to X, Y sub 1 statistics and click that. A pop-up window is going to come up. You're going to scroll down to correlation coefficient, and that will give you your R value. Okay, and that's what we're trying to find. Whatever that R value is, that's your answer. Here's number 15. List the following correlation coefficients in order from strongest to weakest. The strongest correlation is R equals 1 or R equals -1, but we don't need to worry about that because they're all positive. So the strongest one is going to be closest to R equals 1. So it's going to be the highest number down to the lowest number. You just need to put those in order. Where am I? Right here. Number 16, based on the data, which of the following choices would be the best estimated correlation coefficient? So this, the straighter the line is, the closer all the dots are to that straight line, the higher the correlation coefficient, which means the closer it is to either +1 or -1, okay? And whether it's positive or negative depends on the slope. So if it's in a perfectly straight line and all the dots are exactly on it, it's going to be +1 or -1. If it's off just a little bit, it will be really close. If it's off more, it's further away, okay? You can do this. I believe in you. Number 17, the residual of the data point is blah. Okay, so to find out what the residual of this is, the easiest way, you could make a table and put in all these points, but the easiest way is to use algebra. Put in your formula, okay? Then you're going to click the 3 dots next to it, and it will drop down, and you can go to X. Oh, you probably need to make the table first. You could make the table. Okay, which you do that by, I'm looking in my notes right now, to create a table. Sorry, I'm looking. You click next to your formula, and it drops down, and I think there's like create table, if I remember right. I don't think this is in my notes, and I apologize for that. So if you can't figure out how to create the table, then go ahead and put these in as your table values, okay, and it will create a line. Anyway, then once you have your line, you go next to y sub 1, click the three dots, do the drop down, do the x y sub 1. I'm sorry, I'm looking for it and I'm not finding it. Whatever the x y sub 1 is. Are we doing, we're looking for the residual. Residual, I'm on the wrong page, that's why. Oh, here's the xy chart. So you type in your formula, you do the 3 vertical dots next to the equation, you click table of values, and then you put in your x values. No, you just click through OK on all of that. I remember that. And then you go to the 3 vertical dots to the right of, you have to copy them over into the next column because it does f of x to make a y sub 1 column. And then you do the 3 dots next to the y sub 1 column, and you do x y sub 1 statistics. Scroll down to the correlation coefficient, and then you can get your residual value, which is written as the r value, and you can put it in here. I'm sorry that took me so long. Here's number 18. A social sciences researcher is studying data from a survey she collected. She notices that there is a correlation between height and the number of salads consumed. Can the researcher conclude that being tall causes participants to eat more salads? It has everything to do with correlation and causation. The title of that whole section gives you the answer to this question. You should know this. If it's not a scientific study, then blah. Okay. Here's number 19. Which type of function best models the data in the table? So to figure this one out, what you do is you go to GeoGebra, you click in table, you put all this information in, it graphs it, and then you're going to click into your y sub 1 little 3 dots. You're going to go down, and it gives you options to change from like linear to growth to quadratic, and whichever one has the highest R value, has a perfect 1, that's the one that's going to match this. Now, if you have 2 that both have a perfect 1, choose the one that when you look at the graph, it looks the most like it. Like it has the quadratic parabola, or it looks like an exponential curve, or it's a straight line. Okay. 20, given the XY chart, create a function model. What is the formula? And does this illustrate a linear function, an exponential function, or a quadratic function to represent the data set? This is just like the last one. Go to GeoGebra, make your table, look at your graph, and then you're going to go to your 3 dots next to your y sub 1, and then you're going to go look at your correlation coefficients, and you can change it from linear to growth to quadratic. You don't use exponential, you use growth. See which has the highest R value, and then if you need to, look at the graph and see which shape makes most sense. And here's 21. These are all of your definitions that you need to sort. Do not rush this. This can drop you like a whole letter grade just because you're being sloppy. It's over. You did it. I'm proud of you. Go eat ice cream.